Hi students, welcome to Alpha C Learning Program Mathematics class. In previous session we have observed students some properties basing on here normal equation. Okay, using normal equation we have discussed here about circumcircle, centroid, orthocenter, etc. we have discussed. Now observe here this problem. The problem is nothing but here locus of point of intersection of three normals. Okay, three normals drawn to a parabola y square equal to 4ax. Under what condition? Locus means every time we require a condition. To the first problem, the condition is two of those normals are mutually perpendicular, and the second problem it is nothing but two of the normals they are coinciding. Okay, so let us observe students how to do here. Whenever a problem is given, locus of point of intersection of three normals. Okay, we have observed earlier two tangents, because to a parabola from a point outside we can draw two tangents. Therefore we observed locus of point of intersection of tangents under different conditions. Now this is basing on normals. Okay, so what is equation of normal to this particular parabola? It is nothing but we know y plus xt is equal to, what is the value? 2at plus at cube. So this is our equation of normal. Now locus of point of intersection implies, suppose this is the parabola we are having, and now one normal is drawn at a point and another normal we have taken again like this, and next normal is like this. In this way they are coming. Now you observe students, this normal and this normal we have taken as right angle. Okay, if these two normals we observe, it is a right angle, and this is the point of intersection of three normals. Okay, so let this point be suppose x1 comma y1, which is any point on the locus. Like this, here you take again another 3 points, again two of them are perpendicular, then they intersect at one point. So if you take three normals in this way, one set like that, among them two are here perpendicular, then what about locus of, that means here this is x1 y1, and if I take another set in this way, suppose again that set is perpendicular and this is suppose x2 y2, like that if you take different points of intersection, what about locus of all such points? That is our question. Okay, now let us take here one of the points on the locus, that is x1 comma y1. So if x1 comma y1 is any point on the locus, then it has to satisfy the equation. Then if we substitute, the equation is nothing but at cube plus, it is t, if you take common, 2a minus x1 minus y1 is equal to 0, right? And this is the condition. Now what about here the values? You know here it is a cubic equation. This said already three normals are there. Therefore we can write here sum of the roots t1 plus t2 plus t3 is 0, and sigma t1 t2 value is nothing but how much here? It is 2a minus x1 divided by a, and again product of the roots is nothing but here it is minus of minus plus y1 by a. Using cubic equation we have observed these kind of values. Now what is the given condition? Suppose a normal is drawn at t1, another is at t2, and next one is at t3. Okay, then two of them are at right angle. Okay, what about slope of each of the normal? Now you know clearly slope is nothing but how much here? Minus t. Okay, at the point t, if you take minus t is the slope. So if I observe at t1, okay, at t1 slope of normal is nothing but how much here? At t1 means all of you understand it is at at1 square, 2at1. Slope of normal to the parabola y square equal to 4ax is nothing but how much? It is nothing but minus t1, right? And similarly at t2 it is minus t2. Then what about here? Basing on the given condition, product is nothing but how much here? Minus 1. So we consider minus t1 and into minus t2 is equal to how much here? Minus 1. Okay, because the normals I am taking drawn at t1 comma t2 are here perpendicular. As normals drawn at t1, okay, drawn at t1 comma t2, okay, comma t2 are here, how are they? Perpendicular. Therefore we got product of slopes equal to minus 1. Now let us substitute, that implies t1 t2 is how much here? Minus 1. So let us substitute the value here. Therefore, what will happen here? Minus T3 equal to y1 divided by a. Okay. Then T3 equal to minus y1 divided by a, which is nothing but one of the roots of this equation. Okay, one of the roots of this equation. Therefore, we can substitute this T3 value here, which has to satisfy the equation. Then if I write here, it is nothing but a t cube, implies it is minus y1 divided by a whole cube. Okay, and next value plus t, that is minus y1 by a, and into 2a minus x1. Okay, and next value minus y1 is equal to 0. So minus y1 is equal to 0. Now one of the value, students, you can take here minus y1 as common. Okay, y1 is 0. y1 is 0 means it represents actually a line, that means again x-axis itself. So suppose the locus is not x-axis, then we are talking about this. So I am dividing by minus y1. Then what is this value here? A into minus vanishes, therefore y1 square divided by here a cube, minus here divided, and here plus 1 by a, and into it is 2a minus x1, and here it is plus 1 equal to 0. So we divided by minus y1. And then here one value we can cancel, and now let's take LCM, that is y1 square and plus a into 2a minus x1 and plus this value a square, we have taken LCM, a square is equal to 0. Now what is the nature of this locus? Let's have a glance, because this is one of the important problems. So we can observe here the locus how we got. Now y1 square I am writing one side, and the other value, suppose if you take to the other side, this is 2a square and this is a square, right? 2a square plus a square implies the value minus 3a square, and next one it is minus ax1. So if I write this side plus ax1, now if I take here a value common, then it is x1 minus 3a, right? So this is here the locus of point of intersection of three normals, of which two are perpendicular. Hence equation of locus can be written as here y square equal to a into how much? It is x minus 3a. So students, you can observe here, sometimes they ask here what is the focus of locus of point of intersection. Okay, they may ask the question, what is the focus of locus of point of intersection of the three normals? Then to this one, this is a parabola, you know, and after this whichever value they ask about focus, vertex, tangented vertex, you can find easily, right? Therefore here after writing this kind of equation, you can observe many values they may ask basing on this one. Okay, now let us observe, students, the second one. Okay, second problem, it is given as two normals are coinciding, okay, under the same condition here, but two of them are here coinciding. Okay, now what is the equation of normal? In the same way we write, just like our previous problem, we write in the same way the equation of normal, which is cubic equation, and p of x1 y1 be any point on the locus, therefore the point must satisfy the equation. Then how much will get? at cube plus 2a minus x1 and into t, and this is minus y1 is equal to 0. So in this way we can obtain the equation, okay, where x1 y1 is any point on the locus. Now in this problem again I am writing t1 plus t2 plus t3 equal to 0, and next sigma t1 t2 is equal to here how much the value? 2a minus x1 divided by a, and the other one is t1 t2 t3 is equal to product of roots is nothing but y1 divided by a. So in this way we are writing. Now here they are telling two of the normals are coinciding. So we have observed actually slope of normal at t, okay, slope of normal at t is nothing but what is the value here? Is minus t. So this is our formula. Now here we observed they are coinciding, implies both the slopes are one and the same. So here any two you can consider T1, T2 or T2, T3, any of the combination. Suppose we are taking T1 is equal to T2, okay, or you can say minus T1 is minus T2. Slopes are equal since, okay, since normals are, two normals are here, how they are coinciding. Since two normals are coinciding, therefore we are writing here what is the value, their slopes are equal, minus T1 is minus T2, that implies T1 is T2. So let us substitute here and here, anywhere you substitute such that eliminate here the parameters T1, T2, T3. Suppose I substitute here one of the values, it is T1 and T2 are same, so 2T1 plus T3 equal to 0, right? That implies T3 equal to this, or you can. And again if I take this equation T1, T2, T3, this implies T1 into T1 again, okay, T1 square T3 is Y1 divided by A. Now from these two you can eliminate one of the values. So here I can write T3 value as Y1 divided by T1 square A, or from this we can substitute. So I am substituting from here, that is T1 square into T3 means minus 2T1, okay. From this we are writing T3 as minus 2T1, and this is equal to Y1 divided by A. That implies minus, this is T1 cube, okay, and into 2 also there. So this is Y1 divided by 2A, or we can say T1 cube is nothing but minus Y1 divided by 2A. So in this way we got, students, from the value T1 cube is minus Y1 divided by 2A. Or now this value you need to substitute in the given problem, okay. What is the given problem? Actually T cube value we substitute as it is, no error. But what about here, it is coming T only. That means you take here 1/3 of this value, minus Y1 by 2A to the power of 1 by 3, and next minus Y1 is 0. Thereby we can do here simplification. And the other method also there. Suppose if you take this value, that is T1 T2, okay, plus T2 T3 and plus T3 T1, and this value we know it is 2A minus x1 by A. Then from these two values, if you take here T2 common, you will get T1 plus T3. Then also you can substitute one of the values, thereby we can obtain the answer. So now I am preferring here the method, that is substitute this value in the equation, okay. So if I substitute the value in this equation, then what about our values? So it is A T cube, because T3 is, or T1, T2, these are roots of this equation. That is the intention of substituting again in this equation. So A into T1 cube implies minus Y1 divided by, this is 2A, okay, directly we write. And next here plus 2A minus x1, and into, what about here T value? T means it is minus Y1 by 2A to the power of, what is the value here, 1 divided by 3, okay, only T1, and minus Y1 is equal to how much here, 0. Then let us here take the term which is with irrational value to the other side and left over other values on one side. Now A and A get cancelled here, okay. Then we are taking these two values into consideration. So minus Y1 by 2 minus Y1, that is nothing but minus 3Y1 divided by 2, okay. And now let's take this value the other side, that is x1 minus 2A, and into it is minus Y1 by 2A to the power of 1 by 3, right. And we have taken to this side, therefore I wrote as x1 minus 2A. And now let's cubing both the sides, okay. If you take cubing both the sides, then what about this value? It is minus 27 y1 cube divided by 8, right. And this side it is x1 minus 2a whole cube, and into it is minus y1 divided by 2a. So as it is you can observe. Now this 2 value we can cancel here 4, and this minus we can cancel. At the same time divide by y1 when y1 not equal to 0. That means the locus, if it is not our axis, then what is the leftover? It is 27 y1 square, okay, divided by 4. and this side it is equal to x1 minus 2a whole cube and divided by what is the value we got? A. So we divided both the sides by minus y1. So now this is the locus equation and we remove the suffix to write the final answer. Therefore, the locus of point of intersection of three normals drawn to a parabola, of which two of them are coinciding. Then we have taken here T1 is T2 and T3 is the other one, and thereby we obtain this is the locus equation. 27y square by 4 is x minus 2a whole cube divided by a. Okay, now let us observe, students, the other one also. Now observe, students, this one, point of intersection of normals drawn at T1 comma T2 is nothing but to the parabola y square equal to 4ax. Okay, this is only for parabola. Y square is 4ax. We can write this formula. Earlier we have observed point of intersection of tangents. Okay, tangents drawn at T1 and T2 is a T1 T2 comma a into T1 plus T2. Of course, this formula compared to it a bit lengthy, but if you remember, it will be easy to you whenever problems asked again locus of point of intersection of only two normals. Observe the difference. Here problem is basing on three normals, okay, but here this formula is exclusively only for two normals, okay. So point of intersection of normals drawn at 2 points T1 and T2. That implies if you take a parabola, y square is 4ax, a normal is drawn at this point. So this is a tangent and this one is the normal drawn at T1. And next another normal is drawn here. Another normal is drawn at T2, suppose this one. And now these two are intersecting, right? These two are intersecting. Now this point of intersection, the formula is this one. That is 2a plus a into sum of these whole square minus etc. This entire value. So in this formula also, students, you can observe one thing. That is you are obtaining sum of the values. That means parameters and product of parameters. Therefore, they may design some problems basing on locus just based on sum of these values and product of these two values. And how we got this formula? Just take the two formulae and solve the two equations. That is y plus xt1 equal to 2at1 plus at1 cube, and the other is y plus xt2 equal to 2at2 plus at2 cube. Okay, and now here if you do subtraction, y get cancelled, then x value you just write t1 minus t2 equal to here 2a into t1 minus t2, and this one is plus a into, again you know, a cube minus b cube formula, that is t1 minus t2 into this is t1 plus t1 square plus t2 square plus t1 t2. Okay, now cancel t1 minus t2 throughout, then 4 we can obtain here x is 2a plus a into this entire value, but we wrote this value like this, t1 plus t2 whole square. Okay, instead of like this, if you write, then to so many problems it will be useful. A plus b whole square, just we wrote like this, then it is t1 square plus t2 square plus 2 t1 t2 minus t1 t2, that is nothing but again the same value. Okay, now again ordinate, if you substitute in one of those, you can obtain clearly ordinate value also. Okay, so better remember this formula so that it will be easy to you to solve any problem basing on point of intersection of normals, right? Now let's observe, students, the problem locus of point of intersection of normals. Okay, point of intersection of normals drawn at the ends of parallel chords. Okay, parallel chords. Suppose I am taking here a parabola. Okay, now this one is a chord. This is a chord. Now at these ends you are considering two normals. Understand? So from here if I take a tangent, then this is one normal. Again here this is another normal. So you got here x1 comma y1 as point of intersection. Next again another chord we are taking. How is the other chord? They are telling parallel chords. Okay, they are telling parallel chords. Another chord I am taking like this. It is parallel to this one, and all of them are having here slope as m. Now again if you take here normals at these ends of these two, okay, at the ends, then here they intersect at some other point. Okay, suppose this point of intersection is x2 y2. Now another parallel chord you consider, this is the other chord, right? And now again you draw here some, this is a tangent, here tangent. Now normals we are taking, suppose these two normals are intersecting at some other point and this is x3 y3. Now what is the question, students? Here the locus of point of intersection of normals, that means this one etc., and how are they drawn at the ends of parallel chords. Okay, the two normals you are getting, like these two normals we are getting, and these T1 and T2 are nothing but here those are ends of one chord, and next one again another chord we have taken, and again ends of you are considering. Like this, if you join all these points, what is the locus? That is our question. Now again students, let us fix here one of the positions. Suppose a chord we are taking and they said the slope of chord is nothing but m. Okay, so that is given in the data, and moreover this problem is here for the parabola y square equal to 4ax. Therefore parabola is y square is 4ax given, and now here we are taking, this is suppose one of the chords having slope, already they said it is having slope as m. Okay, so slope is m. Now what is here? Slope of line joining, right? Slope of line joining T1 comma T2. This is T1 comma T2. It is equal to, you know the formula, it is nothing but 2 by T1 plus T2, right? And now, but they said the chord slope is how much actually? M. So we are taking this value as how much here? M. That implies here T1 plus T2 is nothing but, how much is the value? 2 divided by m. Understand? Now what is the data? If this is a chord, now we have taken in the problem for our convenience at1 square to at1, at2 square to at2 as the two parameters. And next one, this is the point of intersection of normals. Let x1 comma y1 be one of the points of intersection, which is any point on the locus, right? And now what is our condition here? We have to eliminate these T1 and T2 using the condition that slope of chord given as how much here? M, right? Now you know here students clearly the point of intersection of normals. Otherwise what we have to do? You have to take normal equation and you have to take here just now whatever we have done in that way, again substitute, but that simplification is a bit lengthy compared to using this kind of formula, right? Now from this one, what about our T1 T2 value also? Let us have a glance what is T1 T2. So if you do square this value, how much you can get? T1 plus T2 whole square. Okay, so this value you can get here, and if you expand T1 square plus T2 square plus 2T1 T2, but this only sufficient to us to solve the problem. So let us write here, let x1 comma y1 be any point on the locus. Okay, be any point on locus, then this is what actually our point of intersection of normals. Okay, which is point of intersection of what here? Normals. Okay, point of intersection of normals, where they are drawn here, drawn at which points here? T1 comma T2. Okay, at T1 comma T2. Okay, now therefore I am making use of the formula x1 comma y1 is equal to, the formula if I write 2a plus a into T1 plus T2 whole square, then I am substituting this result. Okay, no? Then if I write this value, it is 4 divided by m square minus T1 T2. Okay, and next value comma minus a into T1 T2 and into T1 plus T2 means 2 divided by m. So if you take this equation as 1 here, let's write this value as here from 1. So this is the point we have taken from the formula, point of intersection of normals drawn at T1 and T2. Now what is the only unknown you are observing in abscissa as well as ordinate? T1, T2 is the only unknown. So if you equate x1 and y1, clearly you can eliminate that particular value T1, T2. So how to eliminate that one? First let us observe here. Ordinate seems to be easy. So I am taking here ordinate. So y1 is equal to, if I take the ordinate, y1 is minus 2a t1 t2, right? 2a t1 t2 divided by m. Therefore t1 t2 is equal to, how much is our value? my1 divided by minus 2a or minus my1 by 2a. This value you substitute in abscissa. Let us write here, suppose if this is actually our 2, then I am writing here, therefore we are considering now abscissa. So what is abscissa here? The abscissa is nothing but x1 is equal to, okay, 2a plus a into, understand, a into, it is 4 by m square. Already we are having this value, minus t1 t2, I am substituting this value. Already minus is there, so plus my1 divided by how much? It is 2a. So if we do simplification, this is our locus. M value already given in the problem. M, they said here, the slope of parallel chords. So M value already in the problem, and x1 y1 is any point on the locus, and this is for the parabola y square equal to 4ax. Understand, students? So this is just to remove the suffix, that will be our equation of locus. Now students, let's observe about the concept of number of normals. Okay, number of normals. Suppose a parabola equation is given and a point x1 comma y1 will be given, and parabola equation, suppose y square equal to 4ax or x square is 4ay, but now we are doing complete concept basing on y square is 4ax. In the same way you can develop the concept for x square is 4ay, etc. Suppose if it is given as for x1 y1, which is a point in parabola, y square is 4ax, then how many normals can be drawn from the point x1 y1 to the parabola? That means how many means here at a point, they are not asking at a point. At a point, all of you know, it is one and only one normal. But again proposition, they are asking from a point, okay, from a point. Just now we have observed here, two normals are coinciding, okay, or in this way, suppose you have taken, then how many normals can be drawn? Seems to be 3 are there, but every time it is not convenient in that way. So in what, under what conditions these are satisfying? So this is our discussion now. Then to that purpose we have taken here the equation of normal, and if those are passing through x1 comma y1, okay. So from a point x1 y1 to a parabola y square equal to 4ax. So this concept is here from x1 comma y1, right, from x1 y1 to a parabola y square equal to 4ax. So this one we are taking, how many normals we are taking? Now first this is our equation, all of you know, many times we have used this one. So once you got this equation from the normal equation and the normal is passing through x1 y1, using that you got, students, this kind of equation, right? And now if I take here the equation which is cubic equation in T, now we are tuning back completely towards the cubic polynomial, okay, cubic polynomial. Now students, you know, it is a third degree equation. A third degree equation, you know, here how many roots exist? 3 roots definitely exist, but our interest is number of real roots, okay, real roots. How many real roots exist? Then we have observed already the concept of cubic polynomial in our theory of equations as well as in maxima minima chapter. Same concept we are adopting even here also. So f of t we have taken as this kind of cubic polynomial, and now f dash t value we are considering. So f dash t we have taken the differentiation with respect to t. We have taken, we got this value, then t square value, because our variable is t, okay, t square value we got x1 minus 2a by 3a. Now what about t values here? Plus or minus under root of. That means these values are nothing but here roots of f dash t equal to 0. Okay. Now what is the meaning of these values actually? F dash t equal to 0 implies here t values you got 2 values. Okay. 2 values of t we got. The meaning is nothing but f dash t equal to 0 is having 2 distinct roots. Okay. 2 distinct roots implies minimum and maximum value of f of t can be obtained. Then let us take, instead of taking the big value every time, let's consider that value as alpha is this, and therefore minus alpha is the negative value. Now our interest is what is f of alpha into f of minus alpha. What is the reason why this is our interest? So the reason is, students, cubic polynomial is of this type. Okay, or it can be of this type also. You can select any of those. Okay, either this type you can select or this one also you select. So cubic polynomial graph, all of you know, this is of this model, or else it can be like this. Okay, here how many roots it is having? 3 distinct roots. When the curve is meeting x-axis, whatever the points of intersection, those we call them as roots of that particular cubic equation. And now you got alpha and minus alpha. Here you are getting the local maximum and here you are getting local minimum. That's why we have taken here f dash t. Okay, so to observe the nature, we require about this alpha and minus alpha. Suppose you got f of minus alpha into f of alpha. How is this value? It is above the x-axis. This is falling below x-axis. Then the product is nothing but how much here? Negative, right? So here the product f of alpha into f of minus alpha, this is nothing but how much here? Negative. So what is the conclusion when the product is negative? The conclusion is nothing but here 3 distinct real roots exist, right? 3 distinct real roots exist implies the conclusion, as far as this case is concerned, it is nothing but 3 distinct normals can be drawn. Okay, so what are the roots actually? The roots are t1, t2, t3. Understand, t1, t2, t3, those are the roots implies, those are distinct implies 3 distinct normals can be drawn. And next one is here f of alpha into f of minus alpha, and here one of the values is touching here x-axis, implies here what is happening? 0, right? As it is falling on x-axis, our curve is x comma y, implies x comma, here it is f of x, right? So usually this is our notation, and here alpha we are taking, therefore f of alpha is 0 exactly on x-axis, right? And now therefore in this way, what about this value here? It is equal to 0, and whenever this value is 0, the conclusion is here nothing but 2 are equal roots. Okay, 2 are equal roots and one is the other one. That implies 2 normals are coinciding and one normal is different. Altogether 3 are there but 2 are coinciding. Okay, 2 equal roots. And that already we have done just now, one concept, locus of point of intersection of coinciding normals. Okay, so now again here you observe cubic polynomial, there must exist at least one real root, and therefore this is that at least one real root you got here, and this is the root you got, and here exactly at minus alpha you can find here the local maximum, and alpha you are finding here local minimum. That implies here f of minus alpha is above x-axis, f of alpha is also above x-axis, there you are getting f of alpha into f of minus alpha is positive. Hence to decide the number of normals you require finally what? F of alpha into f of minus alpha. That is the purpose of taking f of alpha into f of minus alpha. Implies where you have to substitute here, we substitute a alpha cube plus 2a minus x1 into alpha minus y1. Okay, here we substitute the value, and if you do simplification, you can obtain simply this kind of condition. And once you got this condition, students, after you substitute alpha value here and minus alpha value here, taking the product, you are obtaining this condition. Only just to our remembering purpose, we are taking multiply divide by a square, okay, because it will become then a cube. 27a cube you can send completely inside. Only this is just for algebra purpose, we multiplied divided by a square. Then this value simply we are taking as g square. G square means y1 square by a square, and 4 times this is 4h cube implies this value. Okay, so if you write in this way, then nothing but a square into g square plus 4h cube is our f alpha into f of minus alpha. Of course a square is positive, right? And that implies now f alpha into f minus alpha less than 0. What is our conclusion? So our conclusion is here, this implies how many roots are existing here? This is g square plus 4h cube value less than 0, right? This value less than 0, and x1 y1, whatever point x1 y1, this is nothing but from which point they are asking, that point it is nothing but, okay. Now this is less than 0, so number of normals, how many here? 3 distinct normals. So this is the case, okay. So here the conclusion is 3 distinct normals can be drawn. And next one, if it is equal to 0, then here normals are 2. Then we can understand 2 normals to a cubic equation, how it is possible, because 2 roots cannot be, 2 real roots cannot be, one can't be imaginary roots, as all the coefficients are here real coefficients. Therefore here 2 in the sense, the meaning is 1 is repeating. The meaning is here g square plus 4h cube is equal to 0. That implies 2 normals, and those 2 normals implies 2 are coinciding and 1 is coming. As a whole we say here 2 normals exist, right? So how are 2 normal students here? 2 are repeating, that means 2 are coinciding and 1 is the different one. Coinciding and the other is different. And next one, suppose this value is greater than 0, okay, greater than 0, then what is the conclusion? That implies g square plus 4h cube, if this value is positive, then the conclusion is nothing but there exists how many here? 1 and only 1 root, implies there exists here only 1 normal. So in this way we can decide about number of normals drawn from a point x1 y1 to a parabola y square equal to 4ax. Simply we can decide in this way. What is the maximum number here? You can observe 3, and what is the minimum number? It is nothing but 1 normal, okay.